Hello everybody, welcome to reInvent 2021. My name is Hector Ibarra, I'm a Principal Solution Architect, and today, together with my colleague Jeremy Labadier, who is a Senior Cloud Infrastructure Architect for AWS Edge Services, we are going to share with you how to migrate large-scale websites to Amazon CloudFront. And everything that I'm going to share today, it's all regarding our experience and how we did this over the time with several customers. Just to go a little bit through the agenda, the first thing that we're going to talk is why customers are choosing AWS Edge Services. Then I'm going to talk about the frequent migration challenges that our customers like you are telling us that you have. Then typical migration plan, the lessons learned that we have through the different stages. Later on, Jeremy will explain and do a dive deep into the most common solutions that we see and how we help customers to really architect the final solutions to be in production. Then we are going to see some migration examples, in particular of one of our customers called OLX, which is a marketplace with more than 300 million active users. And then we will see how you can enhance the security at the edge also to make sure that you can keep the same security level that you currently have, or even better, enhance it. At the end, we are going to have some takes away where you will have some kind of good points that you should remember when you want to move forward and work in this type of migrations. So the first point I talk is about why AWS services, right? And why customers are choosing us to run these migrations. One of the important things that I have to tell you is the innovation speed, right? Customers are choosing AWS because, as you know, over the time, we are always doing innovation, right? And if you compare the numbers of new products and features that we have, for example, in 2020, which were more than 2,700 new products and features, this somehow offers customers the possibility to run faster innovations. Of course, we also do innovation in our edge services, and here you have some examples that our customers are using, like Richplace with Lambda at the edge, where they will able really to solve a lot of authentication problems, right, and authentication challenges that they have by using Lambda at the edge. The next thing is how fast and reliable is the AWS edge infrastructure. We are growing over the time. You will see later on how our global footprint looks today, and that growth also make our very stable services, right? So then customers are really very happy to use our services to make sure that their productions SLAs are always kept and they can really provide what they need for them and for their customers. Another important thing is the AWS integrations. Why that is important? And the reason is because through these integrations, then the developers, they have the possibility to work through a seamless console. They have the possibility to have seamless connectivities between and integrations between different AWS services. So for example, you can use AWS Firewall Manager to manage AWS WAF and update the rules for AWS WAF as an example. And the final point is regarding the cost effective, right? And why that is very important. We see customers really having significant savings when migrating to CloudFront or to AWS services, and those significant savings may come through different aspects, right? One, the most simple aspect is the reduction of the data transfer out. As you are aware, if you are moving data out from AWS, that data transfer out has a charge. But when you use AWS Edge Services or CloudFront, that charge between the region and the CloudFront is for free. Of course, then later you have to add the data transfer out from CloudFront to the final users, but that has a different cost, and then the price reduction is very, very significant. So when we talk about our global infrastructure, what we can see is that today we have more than 275 points of presence in more than 90 cities and 47 countries. That somehow shows the possibility that you as a customer has to leverage AWS Edge Services worldwide. So you don't need to think, as an example, different providers for different regions, because just by using AWS Edge Services, you will be able to deploy globally your solutions from a single point. When we see what happened with the last updates in AWS Edge Services, I would like to talk about some of them. What we have in the screen now, it's just a list of several updates that we have over the last year and a half, but I'm going to highlight a couple of them. The first one, 8 new real-time Amazon CloudWatch metrics. That's very important when we talk about observability, right? So customers are really trying to understand how the workload is operating on AWS, and to make sure that that is really operating in the right way and the expected way, you have to have data to understand that thing. And by having these new metrics, we offer that to our customers, right? The next thing is, if you plan to run a migration through AWS Professional Services, we have an offering to execute this migration to CloudFront. So our professional services can help you not only to assess, but also to run the migration in case you as a customer wants to do that one. Another very important thing is how you can protect your applications, right? How you can protect your workloads. And for that one, we also have another professional services engagement, which is much more related to protecting web applications by using AWS WAF. So everything regarding the security at the edge, then you can leverage also our professional services. Another important thing is real-time login. And why this is very important? It's very important because sometimes customers, they need to take really fast decisions, right? And these fast decisions will need real-time logins, like for example, to implement a specific restriction or specific customizations to your final users. So we do offer that one to our customers. Our customers can go have direct this real-time login and then take whatever action is needed to provide the performance or the capability that is required for your end users. And finally, I would like to talk about CloudFront Functions, which is a service that we launched in 2020, and why this service is very important for our customers. The important thing is that you can execute small pieces of JavaScript code really at the edge in all our point of presence. And here you will have sub-seconds start times for these services. And it's very important because it's talk about that you can execute really fast commands like HTTP redirections, for example, or manipulation of the headers, which are small piece of code, but then at the end you can take big business decisions. The good thing of this one is that it uses high security standards. In addition to that, it handles milliseconds requests, and it can scale really as much as our customers are willing until now. The next point is, let's talk about our migration challenges. When we are talking about this with our customers, they are sharing with us which are the migration challenges that they have. The first one that we always hear is limited agility. And this limited agility is always linked to professional services from your CDN provider. And the reason is because typically our customers have to execute a change in the configuration or update something in their workload, and that requires the engagement of professional services, which has two pains. The first pain, the cost, is a costly service, but the other thing is they have to wait. They cannot do it by themselves. And what they want to achieve is to empower their developers, their builders, to execute these type of things at the end to win agility. The second point is the cost optimization. I mentioned that already early in this slide deck. And it's all about the data transfer out that I mentioned, but it's not limited to that. It's also in terms of security. You know, when you really have a complex security requirement, then the cost of the security solution may explode your CDN cost. And we see customers leveraging AWS services through AWS native services, but also through our partner ecosystems, or they are building or enhancing our services to really achieve the same security level that they used to have with the current CDN provider, but also reducing the cost. The platform standardization is another challenge that they want to resolve. And this is much more linked to how the developers and the teams can have a single experience from the console point of view, from the way of working, from the operations point of view. And by consolidating these kind of things, they don't need to move from one provider to the other, having to learn completely different platforms, an example. Security flexibility is very important for our customers. For us in AWS is priority zero, job zero. And what we see customers here looking is how they can better fit a purpose fraud mitigation system, right? And the fraud mitigation system includes many things. We will discuss them later in this presentation. Additional things, innovation speed. It's very important. Time to market. Our customers, you want to go really fast and provide value to your customers. So how you can do that one? By leveraging the AWS speed of innovation. And we are doing that through also integrations with different AWS services as the time goes by. Another important thing, better insights, and this is also linked to the real-time logins. You as a customer have the possibility to really have control of your data. So what is happening in your workload, you will have the logs, and you can take, for example, analytics of your logs to take decisions that could be real-time decisions or could be decisions that you want to take afterwards at the different point of time. So you don't have to ask for them. You own that data and you can work with that data from the moment zero. And the final point is all about the migration experience. Why this is very important? Sometimes customers, they do not have the expertise in running this type of migrations, or they do not have the right skills, or they don't have the right time to allocate to their skills, to their existing skills. So then they are looking to someone else. In this case, it could be AWS through our professional services, but it could also be an AWS partner who can help you to bring that expertise to you and execute the migration on your behalf. So when we talk about the migration best practices, I would like to start with a quote. This quote is from Daniel Laudero. He's a lead security engineer at OLX Group. I already mentioned OLX Group is a marketplace which has worldwide presence, and they have more than 300 active users, monthly active users in their platform. In this case, what Daniel shared with us was that AWS simplifies the work so much that you can build a solution to fit your organization without much effort if properly planned. They sent out this quote after they finished the migration from the previous CDN provider to Amazon CloudFront. And what I would like to focus here is that simplification is one of the key things. Building the solution, and you can build that solution by yourself, or we can build it for you through our professional services or our partner ecosystem. And by having the proper plan execution point, then you will be able to run this migration very successful. So when we talk about the migration path, how the migration path looks like. Well, the first stage is that we talk about an enablement, a 4-week enablement session. We really were able to migrate enterprise class workloads in less than 4 months. And when we talk about enterprise class workloads, we are always talking about in the order of petabytes, right? So if you are in that range, this is going to be an enterprise class workload. In the first enablement part, we are going to focus in trying to understand what you have, what type of metrics do you have. We are also going to focus on how to upskill your teams and to learn more about your current challenges. And why this is important? Because we want to upskill your team by running immersion days, for example, by having dive deeps with our edge specialists. So then we can really understand what is currently deployed in your infrastructure. The next stage is going to be a proof of concept, which also will take roughly around 4 weeks. And in this proof of concept, we are going to help you to select the right workload, a meaningful workload that at the end will be representative to a further migration. You will receive constant support from AWS Edge specialists, but not limited to that one, also through our product teams, right? They will also be there in case there's something needs to be corrected or we need, for example, a deeper insight. Once we have this POC running, the idea is to collect the results, understand what happened, and go through a gap mitigation to see if there is any point that probably we were not able to fix and where we need to dive deep and work in a different solution. The next thing is the migration planning. During this phase, it's really very interesting to understand which are the different limitations that you may have, for example, with freeze period, with change windows that you may have. So then we are able to fit all of that, and also the scaling elements. It's very important because we really want to be sure that all our services will be able to handle the workload that you plan to put on AWS. In this case, we always schedule weekly meetings with you where we help you to go through all this planning. We will help you to co-develop a migration plan. We will challenge you. You will challenge us also. And at the end, we are going to execute a functional test and a performance test to ensure that at the end, what we need to achieve or what you need to achieve, it is possible and doable. Finally, a migration stage, which may also take 4 weeks. In this migration stage is where we are going to migrate with you the workloads, and we can select different mechanisms. Customers are, for example, using A/B testing or Canary, which is the same depending on the word that you prefer the most. But we can help you to use different techniques there. We can help you to develop the right technique for your organization. And for example, certain pieces of your application may be better to do it with a specific technique, when certain other pieces may be it would be better to do it with other specific technique, and we can accommodate that accordingly. At the end, the scaling of the service completely, where at the end the service is 100% operational in AWS Edge services. So when we go through the different stages and we want to learn more what happened in these stages, if we dive deep into the enablement phase, here we will see a customer which is comfortable with the current solution. It's very proud because in some cases they invested years to configure and optimize. However, customers are concerned about the low agility, the high cost of the solution, and the poor observability control that they have. So that is why they want to really assess a possible scenario to migrate to AWS Edge services. The typical blockers that we have at this stage is that, for example, the technical teams, they do not have experience. I mentioned that already in AWS Edge services, so we need to upskill your teams. Also, in some cases, customers, they have a big security requirements. It could be, for example, advanced bot protection, where they need to protect their endpoints really in an advanced way, and we need to dive deep into those cases. And also another important topic is, for example, the desire to have a fully managed solution, right? And you know, in AWS, we have the builder's mindset where you have to build certain things, but what we always tell you is that if you don't want to build it, if this is not part of your scope, you shouldn't be worried, because we can help you to build that one through professional services or a partner. The initiatives that we take at this stage is we share the architecture that we recommend you to go through after the assessment we did. We engage with our sales specialist teams, but also with our product teams. And we really go through the immersion days part, where we share this knowledge with your technical teams and we try to upskill them. At the end, what we want to have is a team that is ready to go from the skills point of view and from the knowledge. We really have to know which is the service utilization, the current service utilizations that you have, because we need to work on the commercial aspects to see if everything makes sense from the business case point of view. In the next stage, in the POC, the customer wants to drive a POC, but it's a little bit hard to identify which is the right world rollout, the representative world rollout that at the end will help you to take the final decision if you want or not to move. So the typical blockers that we have at this point of time is complex architectures, because as I mentioned before, they were developed over several years, so then it's very hard to understand how they are. So we can help you to first to understand and to recommend new things there. The lack of experience of collecting the right metrics. Sometimes customers have really vague moments in trying to collect the metrics from the current provider. So we help you to really not only get the metrics, but sometimes you need to aggregate those metrics to have the results that will help you to build a business case. The initiatives that we always recommend in this case is to work with us, with your technical account manager, if you have AWS Enterprise support, because your TAM will help you to understand all these metrics and to translate them into an AWS metrics and how we can size the total cost of ownership for your future solution. The expected outcome is that you will have a POC running successfully. You will have a clear understanding of the possible limitations, if there is any, and also you will be ready to take a decision to see if you want to move it or not. And then let's say that you take the decision to move. We will go through the migration planning, and in this case, the typical thing is, okay, how can I run this planning? What is going to be the best way to avoid production outages? Is it better to change the current architecture? Can I have something that is more simple? Can I have something that is more reliable, for example, right? Or better performance? So this is exactly what we do in this stage. We go through the resource availability that you have, the technical challenges, and also how the remediation time of the time will help you to mitigate all the potential blockers that you may have. The initiatives that we have here is basically to build the migration plan with you and to suggest the best practices to execute the migration at the end. The expected outcome is the plan, so then you can get the approval from whoever needs to approve then, a successful migration and performance test, and at the end, you can also be, should you decide to have AWS Shield Advanced, some customers, they need that to have advanced metrics, for example, for the DDoS protection, then this is the right time to activate Shield Advanced. The final stage is the migration itself. So you are ready to go. but you are still concerned about the impact of the migration. So here we are going to focus on making sure that all the services behind the scenes from the AWS side are ready to go. From the scalable point of view, if there's something that needs to be warmed up, if there's something that our product teams needs to learn because you have a huge scaling, for example, then we will work all of that in this stage. At the end, what we want to have here is that all the possible migration times are identified, and that all the possible blockers are also mitigated, and that the migration at the end ends successfully. So the next thing that we are going to do is to dive deep into some of the points or solutions that we see our customers are willing or are looking to solve the current challenges, the challenges that I shared at the beginning. And for that, my colleague Jeremy will share for you some observations and some best practices in a dive deep mode. So I'm handing over to Jeremy for you to learn this part.
All right, thank you very much, Hector. So Hector went over the 4 phases of a migration, but now we're going to dive deeper into migration planning. And specifically, we're going to address 5 common challenges that we see in every single CDN migration that we do. The key here is we want to identify and address these challenges before we start building. So let's go. So it's a bit of a spoiler, but here are the 5 challenges that we're going to cover. First, where do we start? And second, how do we know which AWS services we are going to need? Third, how will we design our CDN configurations? And fourth, once we design those configurations, how will we deploy our configurations and manage and monitor everything that we're building? And lastly, fifth, where should we be deploying everything? Which AWS account should we be using? If you're doing a CDN migration, then chances are some or likely all of these questions are going to come up at some point. So let's dive deep into each one. The first question is where to start. It may sound simple, but migrating a workload from a CDN that you have been with for maybe years or even possibly decades can really be daunting. The key is to take an inventory of everything that you have today. How many configurations do you have, and how many are in use? How many are not in use? How do you organize your configurations? Do you have them grouped at all, maybe by application or by environment? Once you have a rough inventory of your CDN environment, it's time to dive deep into each configuration so that you can gauge its level of complexity and document everything. You're going to want to keep it simple. My advice is to not cover every single bit of logic and every single rule, but instead focus on setting a level of complexity for each individual migration. Something simple like low, medium, and high. When you're done, you'll hopefully have something like what we're seeing here. It'll give you a good idea of what you have today, what needs to be migrated, what doesn't need to be migrated, as well as which of your configurations are complex and which of them are simple. Now that we have a good idea of our CDN inventory, we can move on to the second challenge, which is determining which AWS services we will need. The best way to answer this question is by first understanding what do you have today with your current CDN. Now, you know which delivery products you're using, but how about accessory products? Things like WAF, DDoS protection, DNS, or load balancing. Try to map out everything that you have today so that you can create a reference architecture. Here's an example of what your reference architecture might look like. Now, this is pretty high level, but you get the idea. The goal is that the architecture will include all of the appropriate AWS services that are needed to migrate the entire CDN workload, not just CloudFront. So for example, notice that we're including services like API Gateway or Route 53 here. You also want to make sure that you include security. In my experience, most of the migrations that we have done have had at least several security components, for example, WAF or bot mitigation. Try to approach this architecture critically. You want to try to poke holes in it because it needs to work for all of your workloads that you're migrating over. This is an area where AWS Professional Services can really help. As Hector mentioned earlier, we have several offerings for performing migrations, but also for doing assessments and helping with this kind of discovery. Now that we have the inventory of the current CDN environment and we know how to find out which AWS services we're going to need, it's time to dive deeper. Specifically, how should we be designing our CloudFront configurations? Now, this is a pretty deep topic, so it's very important to make sure that we understand several key design components before we start building. Just like we want to design a reference architecture for our larger AWS environment, we also want to create a reference design for how configurations are built and structured, and we want to account for one-offs and corner cases in that design. Once we understand the key components of a CloudFront configuration, we can understand how to structure a configuration, and then we can create our reference design. Let's start by diving into the components that make up a CloudFront configuration. We're going to start with a distribution, which is really just another name for a configuration. Within the distribution, we have several configuration elements like host names, certificates, logging rules, but we also have several subcomponents. And the first that we're going to discuss are behaviors. Behaviors are the main rule component for the configuration. They apply path-based matching and allow us to select which protocols and methods are allowed, as well as select things like our origins, policies, and functions, which we're going to talk about more here in a minute. As you can see, you can have multiple behaviors within your distribution. The next component are origins, and origins are where you're defining your origin, how to connect to the origin, which protocol to use, as well as several other options. You can define multiple origins and then select the origin that you want to use within each behavior. Next up are policies. There are several types of policies, but the one that we're going to focus on here are caching policies. You can use policies to define cache TTLs, compression types, what gets included in the cache key, what gets forwarded to the origin, and you can create multiple cache policies and then reuse those policies across your behaviors as well as across other distributions. And lastly are functions, which can either be CloudFront functions or Lambda@Edge functions. Functions are a core component, and it's where you're going to define any complex logic for the configuration. And like policies, functions can be reused across behaviors as well as across multiple distributions. Functions are written in common languages like JavaScript or Python, depending on which function type you're using. So now that we know about the components that make up a CloudFront configuration, let's see how they work together in an example scenario. Imagine you want to create a CloudFront configuration to deliver your web application for www.example.com. Now, there are two main components. The first is the application, which uses an AWS Application Load Balancer, or ALB, as its origin. And the second is the static content, which can be accessed at /assets and uses an AWS S3 bucket as its origin. The application should have a 5-minute cache TTL, and the static content, the assets, should be cached for 24 hours. So our first step is to create a distribution. Here we'll be presented with a unique distribution domain name, which we will use later. The second step is to define our origins, and we'll need two. The first origin is going to be called app, and it will point to the ALB. The second origin will be called assets, and it will point to S3. We're going to reference these origins later on. The third step is to define our cache policies. Just like origins, we're creating two. The first will be a cache policy for the application, which will have a 5-minute TTL. And the second will be a cache policy for the assets, which will have a 24-hour TTL. The fourth step is to create our behaviors. And again, we're creating two, one for /assets and one for a default behavior, which we will use for our application. In our assets behavior, we're going to associate both the assets origin and assets cache policy that we created earlier. And in our default behavior, we will associate the app origin and the default cache policy for a 5-minute TTL that we created earlier. And that's it. So the last step, of course, is to go into Route 53 and update the CNAME for www.example.com, which will point to the distribution domain name that we got earlier. Now that we've explored a simple example scenario, let's dive deeper and look at some specific use cases. These use cases are very common. They come up often. I have three for you, but first let's discuss a key design concept, and that is the concept of behavior-focused design versus function-focused design. What do we mean by that? Well, let's start with behavior-focused. Let's look at the example we have here on the left-hand side. Here we have a distribution with 4 behaviors. Remember, behaviors use path or URI matches. Behavior 1 is looking for requests to /API. Behavior 2 is looking for requests for JavaScript files. Behavior 3 for JPEG images. And lastly, we have a default behavior, which is our catch-all. Notice how each one of these behaviors also has a cache policy. Behavior 1 uses a policy that sets a 5-second TTL, behavior 2 a policy with a 10-minute TTL, behavior 3 a 1-day TTL, and lastly we have the default behavior that has a policy that caches everything with a 5-minute TTL. Pretty straightforward, right? Now let's look at a function-focused design. Notice how we only have one default behavior here, and only one cache policy for that behavior as well. We also have a function, in this case a lambda@edge function, and that function we are using to set the cache TTLs for all of the different paths that we're matching on here, API, star.js, and star.jpg. Now there are some pretty big differences between the behavior-focused design and the function-focused design. Behavior-based makes full use of native API and UI components like behaviors and cache policies. However, there are some drawbacks. Remember, behaviors can only support path matches. In this case, that's okay because everything that we have here are URIs, paths, or extension matches. However, if the matching criteria was more complex, such as matching on a combination of things like a path and the existence of a request header, then the behavior-focused approach would not work. One other thing to consider is that this example is pretty simple, with only 4 behaviors. In the real world, we might see a customer needing many behaviors, and that can become difficult to manage. Now, a function-focused design, on the other hand, is simple and clean. There are much fewer components. However, it has its own trade-offs. The biggest being that the function code is actually handled in code, and therefore there is a learning curve. This is a lambda@edge example, and I typically handle this using Node.js, but other languages like Python are supported. So you'll need to have some level of knowledge with these languages to write the function. In my experience, I do not typically recommend one option over the other. It all depends on the complexity of the configuration. So for example, a behavior-focused approach works great for simpler configurations, whereas function-focused really shines when the configuration is very complex. So back to this example. Let's look more at this lambda@edge function. Here you can see the lambda function written in Node.js. In the code, you can see 3 if statements, which have the regex match for /API, star.js, and star.jpg, along with the cache control directives for each one. And of course, the cache policy attached to the behavior will act as a catch-all for everything else that doesn't match and get picked up by the function, and apply a 5-minute TTL. Let's look at another common example, this time redirects. Notice how there is no behavior-focused example here. That is because functions are the only way to implement redirects. In this function-focused example, you can see a sample of the redirect code, and this time we're using a CloudFront function written in JavaScript. There are some subtle differences between CloudFront functions and lambda@edge functions. We really don't need to cover that here, but they definitely have their own pros and cons and shine in different scenarios. Notice in the code that you have full access to both the request and the response objects, so you can easily look at and manipulate things like the request URI, query strings, headers, cookies, and more. The last example that we'll cover in this section on design concepts is another common one, which is setting a response cookie. Specifically, we're going to set a response cookie with the end user's location data. Again, this is something that we would handle with a function, and like the last one, we're going to be using a CloudFront function. Now, these are relatively simple examples, but they're very, very common. If you're curious about how to best handle a certain scenario, don't hesitate to ask when we're done with the session. We've built quite the library of function code snippets, and we have made some of them available publicly in the AWS documentation. If you have something more complex, then we'd love to chat. Don't forget that you don't have to tackle this alone. The AWS Professional Services team can help. Now on to the 4th challenge. You have your CDN inventory, you know which AWS services you're going to need, and how you're going to design your configurations, but how will you deploy, manage, and monitor everything that you're building? Now this section is completely optional, but we believe that planning for deployments and management in advance will save you a lot of trouble later. So first, we recommend taking an infrastructure as code approach. The best way to do this is either by using AWS CloudFormation or third-party tools like Terraform. This will allow you to templatize everything so that you can easily build, deploy, and manage your environment with consistency. The second thing is to consider using the AWS Cloud Development Kit, or CDK. CDK will allow you to programmatically build all of your AWS CloudFormation templates or Terraform configurations. Third, consider using AWS Cloud9, which is AWS's cloud-based IDE. You can build a development environment with all of the required modules and libraries that you need, and then share that environment out to your team so that the entire team is using the same development environment. Fourth, consider using AWS Code Commit for version control. Now, any version control system will do, but the point is to make sure that you are storing your code artifacts someplace safe. And lastly, monitoring and logging. CloudFront metrics are included, and they include stats like traffic usage, top objects, and cache efficiency. But if you want more granular capabilities, then consider using AWS OpenSearch, which uses Kibana and allows you to easily search through your log files, as well as build custom dashboards. Now you know how to deploy, but the next inevitable question is always where to deploy. Well, it's really up to you. In my experience, I typically see two types of deployments. And it really depends on how you've structured your AWS accounts and environment. Do you centrally manage everything in your AWS environment? Then I recommend creating new accounts to centrally manage your CloudFront deployments. However, if you have a distributed setup where each application team owns their own AWS environment, then you can easily deploy your CloudFront configurations in each application account. There really is no wrong answer. It just depends on how you've structured your AWS accounts. It's important to note that regardless of what you choose, you can still control and restrict access to your origins, even if that origin is in a different account. Also, CloudFront to origin traffic is free as long as the origin is in AWS, and this is true even if the origin is in a different account. Once you know which account, then you can start bootstrapping or preparing that account. Try to take an inventory of all the shared services and resources that you'll be using in that account. So some examples could be maybe S3 buckets for logging, IAM roles and users and policies that you might be reusing across the account, as well as maybe setting up ACM if you're going to be using custom certificates in your distributions. Once you have a good idea of everything that you're going to need for the Bootstrap setup, consider adding all of that to a Bootstrap CloudFormation template so that you can automate the entire process later on. We've covered a lot, so let's recap. Now we know where to start, and that's with a good inventory and identifying what we need to migrate. Number two, we know how to identify which AWS services we're going to need. And we want to start by understanding what services we're using today and making sure that we're accounting for the entire CDN workload. And then we want to build our reference architecture. Number three, we know how to design our CDN configurations. Remember to build a reference design and figure out if we need functions or if just using behaviors will suffice. Number four, we know how to deploy, manage, and monitor our environment. We want to take an infrastructure as code approach using tools like AWS CloudFormation or Terraform. And lastly, not only do we know how to deploy, but we know where to deploy. Do we have a centralized account management structure where we can deploy everything in a new AWS CloudFront account? Or is our account structure decentralized where we want to deploy CloudFront in each individual application account? Proper planning in these 5 areas will ensure that your CDN migration to AWS is a success. All right, thank you. And now back to you, Hector.
Thank you, Jeremy. So now that we learn all these options that we have for the migration planning and execution, let's talk about some migration architectures that we see our customers are doing. I'm going to share what was the stage before the migration from OLX Group to AWS. At that point of time, they have a single CDN distribution where all web browsers users were connecting to, and from there they were rerouting the traffic through different countries. A subset of distributions, right? And this one, they splitted the workloads into desktop, mobile, and also static context. And as you can see, everything was duplicated. But when they needed to, for example, execute a change, like a configuration change in the main distribution, the risk of affecting multiple countries was present. So they wanted to change this type of things, right? The different challenges that they have in this type of configurations. What they did is execute something completely different. And in this case, the web browsers, after the migration, they still keep this division between desktop, mobile, and static, but this was specific for each country. So that means that the users didn't have or will not be affected if there is any specific change in a specific given country, because that will only affect that one, and all the rest will remain as they were before. So by changing this architecture, the change risk was mitigated. When we talk about this and how the execution of this migration happened, what you see here is they put Amazon Route 53 as the DNS service, where they put the www.olx.country, and it could be any country as a CNAME there, and they have their previous or the previous CDN DNS service, former CDN service, and there they were using, for example, the CNAME with a specific weight, in this case 225, and then a specific CNAME with a different weight, like for example 25 to Amazon CloudFront. So at the end, this different weight in the workload, what helped them is to say, routing the traffic initially first to the former CDN, and then as time was passing through, they changed the weight, and then more traffic was flowing through Amazon CloudFront. This is how they execute this migration. The other thing is security. When we talk about security and when we talk about fraud, AWS is really a good partner to help you in this one, not only because we do have services that we build, native AWS services that we build for you, but we also have partners. But in addition to that, you can enhance our partners' services with AWS services by building additional solutions that will help you, for example, to solve specific problems. When we talk about fraud, our customers are really interested in all these aspects that you see in this screen. And these are the aspects that OLX wanted to address, in particular talking about account takeover, credential cracking attack, credential stuffing, account creations, content scrapping, and content spam. All of these were challenges that they wanted to mitigate, and they did that as part of the migration itself. How they did that? By building the architecture that I'm sharing with you in this screen. In this screen, you can see that at the very top, just behind the customer, you will see AWS Shield and AWS WAF. With these two services, they were able to cover DDoS protection, application protection, and also bot protection, but up to a certain point. So then they said, okay, how can we enhance these additional points that, for example, are not covered, like adaptive authentication or compromised credentials that are not part of Shield of AWS WAF? For that, they develop or they use Amazon Cognito, because Amazon Cognito, with the integration with their platform, provide such capability to them. They also have multi-factor authentication, one-time password, and also integrations with Google Authenticator as an example. But since this was not enough, because they really wanted to update the AWS WAF rules by introducing mechanisms or a logic that understand how the business is flowing, they decided to take data from the platform, put it into a data lake, and then take actions from that data lake into a native custom solution that they build by themselves. In this solution, they use DynamoDB, AWS Lambda, and Amazon OpenSearch service to build a solution that at the end will trigger or will push the update to AWS WAF, so then they can control who is allowed to enter to the platform or not. In terms of security, what do we have in terms of security? Everything that you see here. So you can really build strong and robust security solutions on AWS. But the most important thing is the integration. I told you at the very beginning, our customers are looking for this integration. And what you have in the bottom, the native integration with AWS security services like Shield Standard, AWS WAF, AWS Shield Advanced, and most important, AWS Firewall Manager, it's really interesting for our customers because they can manage from Firewall Manager, for example, AWS WAF rules, and then build a DevOps solution, which at the end will bring more automation and reduce the operations times and costs for them. So some takeaways. The first thing that I would like really you to remember, yes, it is possible to migrate enterprise class workloads in less than 4 months. We have the experience, we did that with customers of us in EMEA, we did that also in Asia and in Americas. We can help you to gain the experience. So if you don't have the experience, if you don't know how to run this migration, don't worry. We do have that experience, and we can share that experience with you, or we can execute on your behalf the migration end to end. You can optimize complex solutions. So if you develop a complex solution over the time and then you think that that solution is outdated at this point of time, or you can gain more efficiency, we can help you to do that one. And you saw the example on how OLX did that one. We will share more details regarding our customers' experience with you if we go through these migrations, right? Because we collected a lot of learnings. Some of them are in this presentation being shared, but we will have other things that probably we can share with you too. So then that will help you to take the best decision at the time of the migration. And you can enhance the security while bringing more flexibility and also reducing the cost. We saw cost reduction up to 50% in security aspects in some customers who migrated from a legacy CDN provider to AWS CDN services. So with that, I would like to thank you a lot for attending this session. I hope that we were able to bring value to you, and now that you are ready to assess, if you want to contact us, make sure you go through your account manager, and they will be able to engage our specialized edge services team to help you to run and execute an enterprise class migration. So on behalf of Jeremy and myself, thank you very much,